Hello and welcome to my science tutorials. In today's video, we want to look at the part 1 of the application of linear equations. So without further delay, let's begin. So let's start with an example. So we have here the largest angle of a triangle is 6 times as big as the smallest. The third angle is 75 degrees. We are to write A, this information in the form of an equation for A, the size in degrees of the smallest angle, and then solve the equation and find the sizes of the three angles. Very good. Now this, like I said, is an application of linear equations. We need to understand what the question is saying, make it into a formulation and derive our equation from it, solve the equation and find the value of A, or all the angles that the question is demanding for. So we have here the largest angle of a triangle is 6 times as big as the smallest. The third angle is 75. Now, the I aspect is saying write this information in the form of an equation for A, the size in degrees of the smallest angle. So it means the smallest angle is equal to A degrees. Now, if the smallest angle is A degrees, and we know that the largest angle in the triangle is 6 times as big as the smallest, it means that the biggest or the largest, let me use the correct word, the largest angle in this case is going to be 6A, because we've already been told in the question that the largest angle of the triangle is 6 times as big as the smallest. Now the third angle, we were given the value to be 75 degrees. Now if this statement holds true, it means we can go ahead and write the linear equation. So now the sum of the interior angles of a triangle add up to 180. So the sum of the interior angles, we'll be dealing with angles later on in the future. So sum of the interior angles of a triangle equals 180 degrees. So what it means is that if we add the smallest angle A plus the largest angle 6A plus the third angle 75 degrees, we are going to get a total of 180 degrees. So this becomes our equation. Now let's go ahead and solve this equation to find the value of A and then find all the angles. So we have A plus 6A plus 75 is equal to 180. We can group like terms here. We have A plus 6A is equal to then 180. We send the positive 75 to the other side, it becomes minus 75. So A plus 6A will give me 7A. This is equal to 180 minus 75 is going to give me 105. So I divide both sides by 7. My A is now equal to 107 divided by 105, divided by 7 will give me an angle of 15 degrees. So what this means is that my smallest angle is 15 degrees. The largest angle is 6 multiplied by 15, and that is equal to 6 multiplied by 15 will give me 90. And then the third angle, as we were already given, is 75. So if I add the total, 15 plus 90 plus 75 degrees will give me a total of 180 degrees, which is equal to the overall sum of the interior angles of a triangle. Alright, so let's proceed to look at the second example. We have Jack and Jackie are twins, and their brother Johnson is 2 years older than them. The total of their ages is 32. Write this information in the form of an equation for R, Johnson's age in years. What are the ages of the three brothers or the boys? Alright, so let's look at something. We're told that Jack and Jackie are twins. It means they are of the same age. Jack and Jackie are twins. It means they are of the same age. And their brother Johnson is 2 years older than them. We're told that the total of their ages is 32. We have to write this information in the form of an equation for R, Johnson's age. So we're told that Johnson's age should be represented by R. So let Johnson's age be equal to R. Now, if Johnson's age is R, then it means for either Jack or Jackie, one of them, since Johnson is their brother and is 2 years older than them, Jack will be R minus 2 years old. Jackie will also be R minus 2 years old. So if we add this plus this plus R, it should give us 32. Now remember, we are saying Jack and Jackie are twins, so it means 2 times their age. Okay, so we can rewrite Jack and Jackie's age as 2 into bracket R minus 2. This is for Jack and Jackie. So if this holds true, it means that our equation will be equal to twice the age of Jack and Jackie, which is R minus 2, plus the age of Johnson is equal to 32. Since they are twins, we multiply their value by 2. Okay, or we can just add them, which will give us 2R minus 4. Either way, we can either add or multiply it by 2. Either way is correct. So 2 multiplied by R will give us 2R. 2 multiplied by negative 2 will give us negative 4, plus R is equal to 32. Now 2R plus R will give us 3R is equal to 32, plus negative 4 will come here, it becomes positive, so plus 4. So we have 3R is equal to 36. So 3R is equal to 36. We divide both sides by 3. Our R will be equal to 12. Now that we found the value of R, which is Johnson's age, it means that Johnson's age is 12. Now Jack is 12 minus 2, which is 10 years. Jackie is also the same, so 12 minus 2, which is also 10. Now if we add their total age, 12 plus 10 is 22, plus another 10 is 32 years, which is the total of their age given to us in the question. So what are the ages of the three boys? Johnson is 12 years old, Jack is 10 years old, and Jackie is also 10 years old. Alright, so let's have a look at one final example. The length D in meters of a rectangular field is 40 meters greater than the width. The perimeter of the field is 400 meters. We have to write this information in the form of an equation for D and II. Solve the equation and find the area of the field. Now, there is a lot going on in this question. First, we're told that the perimeter of the field is 400. So let me write that down first. Perimeter is 400 meters. Okay, then we were told to solve the equation and find the area of the field. Now we need to find area. What is area? Now we're told that the field is rectangular. All right, another trouble. Rectangular or a rectangle. So what is the perimeter of a rectangle? What is the area of a rectangle? We'll be looking at that. All right, so let's do the deductions. They said the length D in meters of a rectangular field is 40 meters greater than the width. Now it means the length is equal to the length D is equal to D. Okay, so the length is equal to D. Let me cancel this. The width of the rectangular field, because the length is greater than the width 40 meters, it means that to get the width we have to subtract 40 from the length to get a width. So this becomes the length of the width, D minus 40. We already have the perimeter, and then we don't know what the length and the width is. So until we find that, we can solve for the area. Now, what is the perimeter of a rectangle? The perimeter of a rectangle is 2L plus 2W, where the L stands for the length, the W stands for the width. So the perimeter already we were told is 400 is equal to 2. The L in this case, which is the length, is D plus 2. The width, which is the W over here, is D minus 40. So we have D minus 40. So this becomes our equation. So from here we can proceed to solve the problem. So we have 400 is equal to 2D plus 2 multiplied by D will give us 2D minus 2 multiplied by 40 will give us 80. This implies that 400, we can send the negative 80 to the other side of the equal to sign, or to the left hand side. It becomes positive, so plus 80 is equal to 2D plus 2D will give us 4D. So 400 plus 80 is equal to 480 equals 4D. So we divide both sides by 4, and then the value for D, which is the length of the rectangular field, will be equal to 120 meters. So it means that our length for this rectangular field is 120 meters. Our width will be equal to 120 minus 40, and that is equal to 80 meters. Now that we have the length and then the width, we have to find the area of the field, the area. Now the area of a rectangle or a rectangular field will be the product of the length and the width. That is equal to 120 for the length multiplied by 80 for the width. So 120 multiplied by 80 will give me 9,600 meters square as the area of this rectangular field. So thank you so much for watching. This is how we solve some applications of linear equations. This is how there's a problem can be framed on an application of linear equation. You need to look through the question, derive an expression in a linear way, solve it and find the value, and then proceed with whatever the question may demand. Hello and welcome to my science tutorials. In today's video, we want to look at the application of linear equations part 2. So without further ado, let's begin. So let's start with an example. Joe buys 18 kilograms of potatoes. Some of these are old potatoes at 22 cents per kilogram. The rest are new ones at 36 cents per kilogram. Denoting the mass of old potatoes he buys by m kilogram, write down an expression for the total cost of Joe's potatoes. II. Joe pays with a $5 note and receives 20 cents change. What mass of the new potatoes does he buy? Alright, so let's go ahead and solve this example. Alright, so we're told that Joe buys 18 kilograms of potatoes. That's the total mass of the potato that he bought. So let's write that the total mass equals 18 kilograms. Now we're told that some of these potatoes are old and they were sold at 22 cents per kilogram, and then the new ones at 36 cents per kilogram. We were also told to denote the old potatoes by m kilograms. So it means old potatoes in terms of mass is equal to m kilogram. So it means the price of old potatoes, let me make it OP, will be equal to 22 cents multiplied by the mass, because one mass, okay, which is 1 kilogram, is equal to m kilogram. All right, now let's look at the new potatoes. So the new potatoes will be equal to, since the total number of potatoes he bought is equal to 18 kilogram, and then the old ones are m. If we subtract m from 18, we get the mass of the new potatoes in kilogram. And so the price of the new potato will be equal to 36 cents multiplied by 18 minus m, and that will give us the price of the new potatoes. Now, we're told that he paid $4 and he received 20 cents. That means the price of the total mass of the potatoes that he bought will be equal to 480 cents. Because $5, that is 500 cents, and minus 20 cents, that will give us 480 cents. So this becomes the price of the 18 kilogram of potatoes that he bought. Now let's look at the equation. So our total cost over here will be equal to the sum of the old potatoes, which is the price, so it becomes 22m, plus the sum of the new potatoes, that will be 36 multiplied by 18 minus m. Okay, now we know that our total cost is 480 cents, that is equal to 22m plus 36 into bracket 18 minus m. All right, so now we have an equation. So the first expression, this is the solution for I, total cost. This is the solution. So we have 480 is equal to 22m plus 36 into bracket 18 minus m. This becomes the equation denoting the mass of the potato, both old and new, and then the price. All right, so let's go ahead and solve this equation and get our answer. So if we continue, we have 480 is equal to 22m. Then we expand the bracket over here. 36 multiplied by 18, that will give us 648 minus 36 multiplied by m will give us 36m. Alright, so from here we can go ahead and do our grouping of items. So we have 36 here, we have 22 here. Let me bring the m to the other side of the equal to sign. So I'll have 36m minus 22m to be equal to 648 minus 480. Alright, so 36m minus 22m will give me 14m is equal to 648 minus 480 will give me 168. So I divide both sides by 14. The value of m will be equal to 168 on 14 will give me 12, and that is in kilogram. Okay, so it means the mass m, which is the mass of the old potato, is 12 kilogram. Now if the mass of the old potato, so it means old potato is equal to 12 kilogram, then it means the new potatoes will be equal to 18 minus 12, and that will give me 6 kilogram over here. Now let's look at II. Joe pays with $5 note and receives 20 cents. What mass of the new potatoes does he buy? Okay, so we can already see that after calculating for our mass of old potatoes, and we subtract that from the total mass that we have, which is 18, we've obtained the mass of the new potato, that is equal to what? 6 kilograms. So this becomes our II. So the total mass of the new potatoes that he bought is 6 kilograms. All right, let's proceed to look at one more example. We have, in 18 years time, Benjamin will be 5 times as old as he was 2 years ago. We have to write this information in the form of an equation involving Benjamin's present age, and we have to calculate how old Benjamin is right now. Right, so let's look at something. Now, we're told that in 18 years time, Benjamin will be 5 times as old as he was 2 years ago. Okay, so 2 years ago, Benjamin will be, since we are to represent Benjamin's age with A, it means 2 years ago Benjamin was A minus 2 years. This was his year 2 years ago. Now, we're told that 5 times as old as he was 2 years ago means that will be 5 multiplied by A minus 2. Okay, now in 18 years time, Benjamin will be, in 18 years time, if Benjamin's current age is A, in 18 years time Benjamin will be 18 plus A. Okay, now that we've made these deductions from the equation, that the question that we're given, let's proceed to see how we can write this information. So in 18 years time, which is 18 plus A, Benjamin will be 5 times as old as he was 2 years ago. So Benjamin will be equal to 5 times as old as he was 2 years ago. So this is as old as he was 2 years ago, 5 times as old as he was 2 years ago. So this becomes our equation for us to solve. Alright, so let's solve this equation and find Benjamin's current age. Alright, so we have 18 plus A is equal to, let's expand this bracket, 5 multiplied by A will give us 5A, 5 multiplied by negative 2 will give us negative 10. So I will maintain the 18 here and bring the negative 10 to the other side of the equal to sign. It becomes plus 10 is equal to 5A. Then I send this A to the other side of the equal to sign. It becomes A. So I have 28 is equal to 4A. Now 28 is equal to 4A. To make A the subject, I divide both sides by 4. So my A is now equal to 28 divided by 4 will give me 7 years of age. So it means Benjamin is 7 years right now. So if Benjamin is 7 years right now, it means in 18 years time, Benjamin will be 18 plus 7, and that will be equal to 18 plus 7. This will give us 25 years. So in 18 years time, Benjamin will be 25 years old. And let's see whether that is 5 times as old as he was 2 years ago. So that will be 5 into bracket 7 minus 2, and this is equal to 5. 7 minus 2 will give me 5, and this is equal to 25. So we can see that the right hand side of the equation, this side, and then the left hand side of the equation, this side, are all the same, and therefore it means that our answer is correct. So thank you so much for watching the part 2 of the applications involving linear equations. Now I will see you in the next video where we'll be talking about change of subject. So thank you once again, and bye bye.